So this is going to be a really interesting day, I think. Just to introduce myself, for those of you who don't know me, my name is Anneke Lucassen, and I'm the director of the Centre for Personalised Medicine. And here's a bit about the Personalised Medicine, which is a partnership between St Anne's College, where you are today, and the Centre for Human Genetics, which sits within the Nuffield Department of Medicine at the university. And our aim is to explore the benefits and challenges of personalising medicine, and we talk about personalised medicine in the broader sense, any attempt to personalise medicine. So I think today's theme is a very good one of where we want to explore both the benefits and the challenges. So our overall mission is to be a trusted and collaborative partner supporting the development of equitable and effective personalised medicine, identifying appropriate questions, facilitating constructive debate and developing solutions. And do have a look at our website, where I've just pasted a few of the things we've got up there. We've got lectures, we've got podcasts, we've got explainers, lots of and reports from previous meetings. So there'll be something of interest to everyone there. So to set the scene today, I think we could probably all agree on this theme, that we all want to diagnose serious treatable illnesses as early as possible. Is there anyone who disagrees with that? Good, so we don't need to carry on with the day, we've got agreement, and that's fine. And I think it's really important to acknowledge that the success of genome-wide ventures, such as DDD study, the 100,000 Genome Project, and other studies globally, highlight how advances in genomic technologies are really helpful in diagnosing rare diseases. I guess one of the questions for today is, can we flip that to predicting diseases as well as we can diagnose diseases? And I'd say one of the arguments there is that the central dogma that a lot of us talk about, teach about, learn about, that's very much in our day-to-day conversation, is that the variant in the genetic code, the mutation, leading to an abnormal transcript, leading to an altered protein, and that to disease, is maybe too simplistic when it comes to that bottom-up approach of starting with the genome. Because the gene variant, excuse me, the effect depends on the context in which it is found. And that's a complex, dynamic, and often random and unpredictable mechanisms in the cell and the cell structures in which the DNA is located, and mechanisms such as biological redundancy and other compensatory mechanisms that aren't measurable means that that central dogma just doesn't work in the screening setting. So the DNA is not really like a blueprint or instruction manual, although we quite often hear discourses that would hold that. And a really nice summary of that was our annual lecture a couple of weeks ago, that's available on our website, which was by Philip Ball, and I would recommend that book to anyone who doesn't know it, about the complexity of how life works. And as he so poignantly puts it, once we decipher someone's DNA and we analyse it, we still don't have the instructions to make a human. So I think that's worth bearing in mind when we're thinking about screening, whole genome screening. So just sort of riffing on that theme, that if you have a child with a rare condition in which you suspect a particular rare diagnosis, then the DNA variant in the genome sequence can be really helpful in confirming that diagnosis and helping then other family members know about their risks. But what that doesn't acknowledge well, I think, is that the context in which that DNA variant lies is mediated by many other factors, which cannot be measured. And those other factors are sort of, rather simplistically, those coloured circles and cogs. So what we're doing when we're making a diagnosis is we're finding the DNA variant, but we're also finding all the other factors in which that DNA variant lies, but which we can't measure. And what that means, I think, is that when it comes to turning things round and starting with the DNA variant to predict a child with a rare condition, is that if that context is a little bit different, if that variant has been switched off or on at a different time, lies in a different way in the cell, many other factors in a different immune repertoire, for example, then it may have no effect at all. And that really highlights why flipping diagnosis to screening might be more difficult than popular rhetoric would hold. And I think one of the questions that we're asking today is, when we screen more widely, we may change the nature of what we take to be a result. So quite often, certainly starting with genetics as a diagnosis, we have this expectation that it's just about holding up a magnifying glass to the genetic code and finding what risk we are at. But actually, when we unpack a typical human genome, everyone in the room has about 100,000 rare variants. And on average, all of us in the room have about 50 variants in our genome that have been reported at one time or another as disease causing. So it begins to illustrate how difficult it is to weave through a genomic sequence to be able to predict accurately in a currently healthy newborn what they are going to develop. And most of our knowledge about the effect of variants comes from finding them in ill people. That leads to a bias. And what if screening cannot distinguish those who will develop the disease from those who won't in an effective way? And I don't just mean in a cost-effective way, but in an effective way that means that people are falsely labelled or need to go and undergo lengthy investigations. How do we let parents know about that in the setting of a very sort of deterministic expectations of genetics? And how do we factor in those implications? How can we acknowledge and respond to the genetic determinism in many sectors of our society? And how can we mould different conversations about what to expect from genome screening? So I'm just going to give you one example that I'll say up front isn't in the generation study for very good reasons, but just to give you an idea of what some of the problems are here. So Krabbe's disease is a rare and severe enzyme deficiency and due to variants in the GALC gene. And the US advisory equivalent of the National Screening Committee, if there can be an equivalent of that, advised against newborn screening because of insufficient information about overall benefit. But nevertheless, because of I'd say a political will, it was mandated in New York State back in 2006, and it's now mandated in several US states. And there's some nice data there of screening it's many more than 2 million babies now, but a nice paper here showed that of more than 2 million babies screened, the result had many false positives, so much so that the screen had only a 1.4% positive predictive value, i.e. chance of being correct. And the estimated frequency of the disease was 1 in 400,000, whereas the literature had suggested something much more common. Many novel variants in the gene were detected and were of uncertain significance. And what that meant was that of the, I think it was 356 children who were tested positive, only 5 ended up having confirmed infantile Krabbe's disease, and treatment with bone marrow transplantation has helped only 1, the others have died. And the other children who tested positive are all being followed up because it's possible they will at some point develop a milder form of Krabbe's disease. So just illustrating that in the finding of these 5 children, you are committing many more fold children to have investigations for an uncertain condition. So is it possible that there will be similar findings for the generation study that are either less common than will be picked up in the study because of this ascertainment bias of knowing about things through people presenting clinically? And how might we prepare parents to live with such uncertainty? So I think that's some of the questions, very broad brush for today. Rachel, those of you who know Rachel here on the front row, know her cartoons, great summary of the three broad sessions that we've got today. Panel 1 is all about how should screening recommendations take account of these very rare diseases? How do we get the screen through the screening criteria? Panel 2 is all about how should we prepare parents and the NHS for navigating new uncertainties. And 3 is about how can newborn genome studies support parents to engage with what it means to contribute data to research, as well as what it means to have expanded screening. Timetable for the day, you've hopefully all got with a QR code, saving paper. And I just wanted to flash it before we start the day proper. Some of the artwork that you may have seen outside. This is an annual school art competition that the CPM runs, and that last year was about newborn screening. This was the winner. You can see they're all, the whole picture of the baby is made from letters, GATC. And 2 more here, which I think illustrate really nicely how 12 and 13-year-olds are able to think about the pros and cons of screening very nicely. So if the school kids can do it in their art, then I think it's really important that we also keep going with those conversations today.